we will be solving a problem that requires understanding and interpreting scale of a graph. We will begin with the knowledge of the actual sizes of the different squares on a regular grid. There we have the largest square. The largest square on the grid is your 2 centimeter square. It is a square of which each side is equal to 2 centimeters in length. The squares next in size have sides equal to half of the side of the larger squares. They are of side equal 1 centimeter in length. So we have the 2 centimeter square is the largest of the squares. Then we have the 1 centimeter square, which is the square next in size. And of course, each side is half of the length of the side of the larger square. And don't be mistaken, if we are talking about the area, then the area of the large square will be 2 times 2, which is 4 square centimeters, and the small one will be 1 times 1, which is 1 square centimeter. So we will have that being 4 to 1. Therefore, in terms of area, this larger square is 4 times the area of this small one, although each side of the larger square is twice the length of the side of the smaller square. We are going right under the microscope. What do we see there? The sides of 5 teeny-weeny squares are in each centimeter, which is equal to 10 millimeters. So each centimeter is 10 millimeters, and we have 5 small squares right there. Therefore, the length of each of them will be 10 millimeters divided by 5. So each one will be 2 millimeters in length. So there we will have the 2 millimeter squares. Each side is of length 2 millimeters. Therefore, the side of each of the very small square is 2 millimeters. So we have the 2 millimeters, the 1 centimeter, and the 2 centimeters square. And those are the main units in terms of squares that are on your regular grid. Now we will take into consideration the length of the sides of the squares in arriving at the scale that is on each axis. So let us take a brief look at the scales on the axes. Notice what we have there, and it's not very difficult to see. We just have 1 centimeter here, but it is responsible for 10 units. The 1 centimeter square, that's what we're taking a look at. Its side is 10 units. The scale is therefore 1 centimeter is equal to 10 units on the Y, the vertical, or the cumulative frequency axis. 1 centimeter is equal to 10 units. There are 5 little squares here. 1, 2, 3, 4, 5. And the 5 little squares are also responsible for these 10 units. Therefore, each of the little square will be 10 units divided by 5, which is equal to 2 units. Each of these little squares will therefore be 2 units. We will go on the horizontal axis, which is the mass axis, or typical x-axis. On the horizontal axis, 1 centimeter is equal to 1 unit, as you can see. 1 centimeter, 1 unit. There are also the sides of 5 little squares. 5 little squares are present in this 1 unit. 1, 2, 3, 4, 5 little squares are there. Therefore, each little square is 1 divided by 5, which is equal to 0.2 unit. Each of these little squares is 0.2 unit. And there's no doubt that we can see a proportionate relationship, and not only just proportionate, but we can see that the values are easily determined. Because we have 10, then each little one is 2. If we have 1, then each little unit must be 0.2. So if we take a look at the proportionate nature and also the relationship between the numbers, then this conclusion would not be too difficult to arrive at. On the cumulative frequency axis, 1 centimeter is equal to 10 units. Each little square is 2 units. On mass axis, 1 centimeter is equal to 1 unit. Each little square is 0.2 unit.
Download Richard James Mathematics Resources app from the Google Play Store and have all of your examination solutions, instructional manuals, and other electronic books and booklets in one place. Also, have all of our products and services at your fingertips and on the go. Call or WhatsApp 876-351-9689 or 876-318-8848 for all hard copy books and booklets to complement your studies. Significant discounts will be given to everyone who is registered with any of our programs.